Section 6.2 exercises. Problem 1. We know that the cosine of 30 degrees is equal to the square root of 3 divided by 2. Use the formula for the cosine of the difference of two angles to get an alternate way to express the cosine of 30 degrees to be root 3 over 2. Let's look at the formula for the cosine of the difference of two angles. Let's use A and B as our two different angles. First, you can never distribute the cosine through. The algebra there does not work. This is function notation, so we have to use this identity. It's equal to the cosine of A times the cosine of the angle B plus the sine of the angle A times the sine of the angle B. And that's the identity we have to use. So here in our problem, the 90 degrees will represent our angle A, and the 60 degrees will represent our angle B. So for us, the cosine of 90 degrees minus 60 degrees will be cosine of the first angle, 90 degrees, times the cosine of the second angle, 60 degrees, plus the sine of the first angle, 90 degrees, times the sine of the second angle, 60 degrees. Now we find each individual quantity and then perform the arithmetic to get the final answer. So let's see here on the unit circle, 90 degrees is pi over 2, and on the unit circle, the coordinate there at 90 degrees is 0, 1. Cosine means the x-coordinate at that angle, and that is 0. So the cosine of 90 degrees is 0 times cosine of 60 degrees. Let's just put our 30, 60, 90 triangle here. Cosine of 60 degrees, looking through this angle, is put the length of the sides on here. Cosine of 60 degrees is the adjacent length divided by the hypotenuse. This is 2. 1, 2, root 3. Cosine of 60 degrees is adjacent length 1 divided by the hypotenuse 2. It's 1/2. Plus the sine of 90 degrees is the y-coordinate at that angle. So back to the unit circle, at that angle the y-coordinate is 1. And the sine of 60 degrees from our triangle is the opposite length, root 3, divided by the hypotenuse, 2. Root 3 over 2. Now perform the arithmetic. Multiplication by 0 gives 0. Multiplication by 1 gives root 3 over 2. And that's the answer that we're asked to show in an alternate way by using the formula for the cosine of the difference. Now in problem 2, we are given essentially the right side of the identity. So we are given cosine A, cosine B, plus sine A, sine B. And we want to use the identity in reverse. So the cosine of 70 times the cosine of 40 degrees plus the sine of 70 degrees times the sine of 40 degrees will be equal to the cosine of the difference of those two angles. A, 70 degrees, minus B, 40 degrees. So simplifying that gives us 70 minus 40 is 30 degrees. And using our triangle from above, looking through the angle this way, cosine is the adjacent length divided by the hypotenuse, so that's square root of 3 divided by 2. Often with identities, you have to learn to work them both in the forward direction and the backward direction. Okay, now we're asked to prove an identity for problem number 3. That the cosine of the difference of A minus B divided by the cosine of angle A times the cosine of B is equal to the quantity on the right. So I will use my expansion identity here for the numerator and write cosine of the first times cosine of the second angle plus the sine of the first angle times the sine of the second angle. That's the numerator. Our denominator is cosine A times cosine B. Now if I simplify this and work it through, we'll end up at the right-hand side of the identity. Remember never to cross over the equal sign and work both sides, only one side separately. In a fraction, I'm allowed to separate the numerators and write this piece divided by the denominator, plus separate fraction, this part of the numerator divided by the denominator. And that's what I will do. Cosine A cosine B divided by its denominator. And then separate fraction for the second piece of the numerator divided by the same denominator. See, normally when you have a common denominator, you write the denominator one time and then you add the tops. And this is the arithmetic in reverse. Why did I do that? I suppose because I foresaw that this quantity here divides out. Cosine A divided by cosine A is 1, and the cosine of B also divides out to be 1. Here, just look at this as the sine of A over the cosine of A. I'm breaking up this fraction into product of two individual fractions, just to make it easier to see what I'm thinking. And directly then, you can see that sine A divided by cosine A is the tangent of A, and the sine of B divided by the cosine of B is the tangent of B. And that's the right-hand side of the identity that we were asked to show. So moving on to the next problem, number 4. Okay, we're given some information. The sine of A is 4/5 for a quadrant 2 angle. Stop there and draw that picture. Quadrant 2 angle, so there's our angle A. That sets up in quadrant 2 our right triangle. And we're given that the sine of A is 4/5, and the sine is the opposite divided by the hypotenuse. That means we can find the length of the side of the triangle x. We used the Pythagorean theorem there. So x squared plus 4 squared is equal to 5 squared. So x squared plus 16 is 25. X squared equals 9. Taking the square root gives you plus or minus 3. We choose the value of -3 because we are in quadrant 2. So the negative sign here means that we're left of the y-axis. Now separately, I'm going to draw a picture for the next angle given. The cosine of B is equal to 1/2 for a quadrant 1 measure. So here is your angle B. Angle B, we'll label it there. And that is your right triangle in quadrant 1. And the sine is equal to 1/2. That is the opposite over the hypotenuse. So let's put angle B here because we need to label that as a 2 for the hypotenuse. We'll find the length of the side x. X squared plus 1 squared is equal to 2 squared. So x squared plus 1 is 4, which gives us x squared is 3. So x is equal to plus or minus square root of 3. We choose the value of x to be positive root 3 since we are in quadrant 1. All we need to find for the first part is the cosine of angle A. And that is easy now that we have all the lengths of the sides of the triangle known. Go to angle A, and the cosine is the adjacent -3 divided by the hypotenuse 5. And that's how I like to do it, by drawing pictures and completing the acute right triangle, and much easier to see what you're doing that way. Part B, find the exact value of cosine A plus B. Okay, well, with no idea what the angle A plus B is or where it is located, and I cannot draw a picture for it. So indirectly then, to get the cosine of A plus B, we use the similar identity that we used for the difference. This time it's the sum. And that formula is cosine A, cosine B, and a minus sign for the sum of the cosine of two angles, sine of A, sine of B. So there is our identity. We need each of these individual pieces, all of which can be gotten directly from the triangles up above. So we get the cosine of A. Well, we already got that value in the first problem. Cosine of B, so turn here to angle B, and you want the cosine, that's the adjacent root 3 over the hypotenuse 2. So root 3 over 2 minus the sine of A, that was given to be 4/5, so we'll just write that in. Sine of B, and that's the opposite over the hypotenuse looking at angle B. So that's 1/2. Now it's an arithmetic problem. So this is negative 3 times root 3 divided by 5 times 2 is 10, minus 4 times 1 divided by 5 times 2. We already have a common denominator, so we can write our answer as a single fraction, negative 3 root 3 minus 4, all divided by 10. And there's the exact value of cosine A plus B, even though we have no information about the angle A plus B. Third part asks us to find the sine of A plus B. So we need an identity for sine of A plus B. The sine of A plus B is a slightly different identity than the cosine of A plus B. It follows the pattern sine of A, cosine B, plus cosine A sine B. So each individual quantity needs to be obtained, and since we have our triangles, that's easy to do. The sine of A, that was given to be 4/5. The cosine of B is root 3 divided by 2. We got that right up here in this part. Root 3 divided by 2 plus cosine of A is negative 3/5. We got that right here, so we'll steal that result, negative 3/5. And then the sine of B is 1/2, and we can steal that answer from here. So the arithmetic is similar. Multiply the tops here, multiply the bottoms, multiply the tops here and the bottoms, and then write the answer as a single fraction, 4 root 3 minus 3, all divided by 10. And that's the exact value of sine A plus B. An identity. Prove the identity. Tangent of x plus pi equals the tangent of x. Okay, well, one might say that because the period of the tangent function is pi, tangent of an angle plus its period is always equal to the tangent of the angle, and that's true. We could also use an identity for the tangent of the sum. The tangent of A plus B, this is a more lengthy way to do it, is given by this identity, tangent A plus the tangent of B divided by 1 minus tangent of A times the tangent of B. Okay, so A in this case is represented by x, and pi is our second angle B. So substituting these values in, tangent A means tangent x, plus tangent of B will be tangent of pi, all divided by 1 minus tangent x times the tangent of angle B, which is pi. Okay, so now we need, in the unit circle, there's your angle of pi, or 180 degrees, and the coordinates there are negative 1, 0. And tangent of pi, tangent's y divided by x. So that's 0 divided by negative 1, or 0. So let's substitute that in here and here, giving us tangent x plus 0 divided by 1 minus tangent of x times the value of tangent pi, which is 0. So multiplication by 0 here wipes out the tangent of x. And what's left? Just tangent x in the numerator and a 1 in the bottom. And there is our result that we were asked to prove. And that's the end of section 6.2 exercises.